So what I mean by seamless mind uploading, so opposed to like these conventionally proposed methods of mind uploading, you don't have to die first. So we're going to do it while you're still alive, and we're going to make sure that you are the one that's going to live on. But before diving into its like seamless nature of the process, how do we make sure that when you are mind uploaded, you do not become a philosophical zombie? That means you become like just an AI without consciousness. So in other words, how can we test machine consciousness? So one major obstacle in terms of testing machine consciousness is the notion of philosophical zombies. So it was proposed by Kirk first and then by David Chalmers. They are imaginable constructs where they look just like us, behave just like us, but borrowing Chalmers' words, they are all dark inside, so there's no consciousness at all. So this hypothetical existence tells us that, let's say I come up with a machine. I've developed this, it took 10 years to develop. So you cannot present visual stimuli or any kind of stimuli and look at the responses to see or test whether they are genuinely conscious. So, well, my big proposal here, so since we cannot test these machines objectively, we have to test these machines subjectively. That means we need to connect these machines to our own brain and to see for ourselves. But there's one other problem. So there was this guy where a CCD camera was directly connected to his primary visual cortex, and he would claim that he can see, that he has conscious visual experience. But that doesn't mean at all that this CCD camera is conscious. So the final problem is, well, science is about making your own problems and answering them yourselves, is that, so we need a way to connect the device so that we possess subject sensory experience via the device only when the device itself is genuinely conscious. I'm sorry, I don't have time to explain consciousness. I'm talking about subjective experience. You need to buy my book, okay? Well, anyway, so I spent like 10 years in Max Planck, and so under like Nikos Logothesis, he's like the founding father of experimental visual consciousness research. And we are talking about like qualia, when a machine is like doing its objective functions, there's something to be that machine in terms of like Nagel's, but I mean like, yeah, I think I don't need to confuse you with all this shit. So, so anyway, so there's one big nature of our brain that in terms of vision, the right side of our cortex sees left side of vision and vice versa. And the interesting point is that if you split the brain by dissecting the corpus callosum and anterior posterior curvature, Nobel Prize winning study by Sperry proves that there can be two streams of visual consciousness within a single skull. But the problem is, what about our intact selves? I hope there's no split brain people. Okay? Anyway, what about ourselves? So all of like scientific evidence tells us that we are also like a primary primate or like a master-master system opposed to a master-slave system. So once independently, consciousness arises in the two hemispheres, and via these trans-hemisphere connections, our conscious vision is integrated into one. And by the way, this is your last chance to oppose to my test, okay? You have any questions? So given this master-master construct of our biological brain hemisphere, if I replace one of my biological hemispheres with a machine and connect it as though the two biological hemispheres were connected, and let's say I do experience the machine side of vision, then we have to say now, due to the master-master constraint, that now this machine is for sure conscious in terms of at least vision. So this is my test. And you might think, what the heck? But okay, but how do we implement such a test? So how do we construct a potentially conscious machine, and how do we connect it to our biological hemisphere? And coming back to my original point, like killing two birds with one stone. I thought this was a Chinese saying, I don't know, but leads to seamless mind uploading. So first, constructing a potentially conscious machine, I would borrow what we can get from the so-called invasive connectome project. We know that the human brain or the mammalian brain, the macaque brain, is very complex in its wirings, but at least at this point today, we are able to decipher all of the neuronal connections, at least in the Drosophila. And maybe in 10 years, we would have this wiring for human brains. But the problem is, due to its nature, dissecting the brain in few micrometers, you cannot get the quantitative values of the synaptic connection. So I would rely on advanced deep learning methods to train these networks so that hopefully they become conscious. So then what about the brain-machine interface? You might be worrying that I would shove a machine into your skull, but actually that would not happen. So since we are trying to connect the two hemispheres, the biological and artificial, we would like to use the corpus callosum anterior posterior commissure to access, to have read and write access. So I would put a CMOS double-sided, like a very high density electrode array, and somehow, we're on this procedure at Tokyo University. We would try to recover the synaptic connections so the axons don't die out. But given that this all works, we would be able to read and write into all of the axons that connect the two hemispheres to integrate our consciousness in all sensory modalities. So, okay, so hopefully in 10 years, okay, what's that?
7 minutes.
Okay, 7 minutes left. Okay. So yeah, so hopefully in 10 years, if I get enough funding, I would try to make this happen with a macaque brain using vision. And 10 years from there, probably, we would be able to construct a conscious hemisphere with all of the modalities, including the 5 senses, decision-making, emotions, everything. And then what would happen is that, okay, today I don't have time to tell you how I would transfer memory to the machine side. This, again, you need to read and write. You need to, read my book. But anyway, I know for sure it's going to work. Wow. Because this is the hard problem. Once I solve the hard problem, now I just need to solve the easy problem. Okay, so anyway, once I solve the hard problem, make sure that these are conscious, then the memory is transferred. What would happen when the biological brain dies? So let's assume that I suffer a stroke in my right hemisphere. So before this stroke, my consciousness resides in 2 hemispheres. But unless my brainstem and all these important parts are not damaged, what would happen is, okay, I would be paralyzed and everything, but I would be conscious in one side of my hemisphere. Consciousness is there, my memories are there without intervening any kind of death. So this is what I imagine would happen with the machine biological hemisphere pairs. So this is what I mean by this procedure. We're going to do it while you're still alive, and you will see that you are still conscious on the other side. And when your biological body goes away, you would become a full, like a mechanical entity. And you could live forever. And if you don't want to live forever, you can skip time or commit suicide or whatever you want to do. Okay, I also don't want to die, don't want to live forever. That's too much, maybe like 2,000, 3,000 years. Okay, so anyway, okay, so what about the dementia, blah, blah, you know? So I'm going to compare my project, the scientific endeavor, to the Apollo project. So development of machine consciousness and providing scientific evidence that it actually exists using my test is something like orbiting the moon with a manned spaceship. But the problem you might notice is that even Kennedy could not gain public support just by orbiting the moon. So he said he would actually land the moon, and make a human being walk on the moon. So this would correspond to the seamless mind uploading that leads to your own digital immortality. But where's the ICBM? So okay, I was on the evil side, evil axis side. So, but the Americans and the Soviets took the former Nazi rocket engineers, and for sure at that time in 1961, the Soviets were way ahead. So Kennedy for sure wanted to deliver the payload with ICBMs. So this is the actual fruit, I think, for the Apollo project. So what about mine? So this is a little scientific detail. How many minutes do I have? 2 more minutes, sorry. Okay. So the problem is the conventional gray matter electrodes cannot write precise large capacity information into the brain. So imagine there's an electrode here, and when you write information into the brain, you have to stimulate by passing current. And let's imagine this is a cat neuron, this is a dog neuron. And if you want to write in precise information, you need to be able to stimulate only 1 neuron per electrode. But the problem here is this is a very scary study. You have electrode here, and this is a 2-photon microscopy image. You can see that passing different amounts of current excite these neurons. So the bad thing is that, let alone stimulating only 1 neuron, it turns out that you're going to stimulate a bunch of neurons. And these neurons, you will not be able to record because they are far, far away. So electrodes can capture like 150 micrometer diameters, but they can be like millimeters apart. So that means, like with conventional gray matter electrodes, you're gonna like just shoot like a shotgun in the dark. So you don't even know what neuron you're writing into. So the problem, this major problem, okay, by the way, the reason is because you're gonna stimulate a lot of axons that lies between your soma and the electrode. Okay, so this is going to solve the problem because we know for sure that if you pass a current here in this electrode, you're going to only stimulate this axon. And we know for sure that what neuron this is. So there is no like shooting a shotgun in a dark problem. There's no read-write mismatch problem. So I believe that this electrode is the only way to go given the Earth-type brains where you have all the wirings in the gray matter. So we can cure dementia, stroke, and other neurological diseases by AI or spiking neural network replacement of neuronal functions using this BMI. Okay, so this is the final slide, and just want to tell you, we're serious about these things, and yeah, if you don't want to die, please fund us.